In this video, I will show you how to find the diagonal of a cube. Now, I could just give you this special magic formula and send you on your way, but I believe it's important to actually understand why the formula works. I'm going to show you the man behind the curtain. I'm going to explain to you the proof of why the formula for the diagonal of a cube works. But first, I need to make sure you remember something called the Pythagorean theorem. A squared plus b squared equals c squared. This means that if we draw a right triangle, we'll pretend this is a right angle, and we label A, B, C. The length of this side squared multiplied by itself plus this side multiplied by itself will equal the square of this side multiplied by itself. So, if we find A and times it by itself, and add B times by itself, and then find the square root of that answer, we have C. Unfortunately, I don't fully understand why Pythagorean theorem works, and anyway, it's a topic for a whole other video, so I'm gonna put a link in the description to a video that attempts to show you why Pythagorean theorem works. Feel free to go look at that and come back. We will be using Pythagorean theorem for the proof I'm about to show you. Say this is a perfect cube. It isn't, but let's pretend. I promise you it's close enough. I like to represent things as tactilely as possible. So this needle is going to represent the line that we're interested in, from this vertex to its opposite. Like this here. Now, in order to find that length, we have to know the length of the edge of the cube. We're going to define 1 unit as the length of one edge of this. Now, if this edge is 1 unit, and this edge is 1 unit, we see the line here becomes the hypotenuse of a right triangle. 1 squared is 1. 1 plus 1 is 2. So the length of this line would be 2. The square root of 2. So, if each edge is 1, then each diagonal of a square is the square root of 2. Here's this line is 1 unit, this line is the square root of 2 units, and this line is where we're going to bisect the cube. Now that we're inside the cube, you can see that this line and this line and the line where we put our needle form another right triangle. So if this side squared is 1, this side is the square root of 2, and obviously the square root of 2 squared is 2. 1 plus 2 is 3. So this line represented by the needle would be the square root of 3 units. And since all cubes have the same proportions, that tells us that if the edge of a cube is 1 unit, the diagonal of the cube from one vertex to its opposite vertex is the square root of 3 units. So, to find the diagonal of a cube, you take one edge, you multiply it by the square root of 3, and that's how that works. So, looking at this cube, if this vertex is 1 unit away from each of these vertexes, it's the square root of 2 units away from each of these vertices. And it is the square root of 3 units away from the opposite vertex. Now, when you want to know the diagonal of a box, instead of following this seemingly convoluted formula, I hope you will have an understanding of why it works, and how you use Pythagorean theorem to find the diagonal of one side of the box, and then use that length with Pythagorean theorem to find the diagonal of the box.